Hello, I'm Latif. In this video, I will explain exponential function along with some example from CAIE past papers.
What is exponential function? Any number to the power x. If we write a function f of x equals to a to the power x, a is any number, we say this type of function is exponential function. As per example, we can say 2 to the power x, 3 to the power x. As per example, 2 to the power x, 3 to the power x, 5 to the power x, e to the power x. E is a special number. E is an irrational number whose value is between 2 and 3. It's an irrational number, we can say 2.718 and so on. To understand the graph of exponential function, we can sketch some graph of exponential function. So if the value of a is positive and x is also positive, it looks like 2 to the power x. If we plot some of the values, x and f of x equals to 2 to the power x. If x equals to 0, it will be 2 to the power 0 is 1. Exponential function is all the functions are positive. That means it will stay above x-axis. If we put x equals to 0, then 2 to the power 0 is 1. If we say x equals to 1, 2, 2, then it will be 4. That means the function will start here. If it is 1, that is 2. If it is 2, that is 4, and so on. The graph will go here. And this is 1. If we take the negative value, that is minus 1, 2 to the power minus 1, that means half, it will go here. So, and it will move here and here. That means the negative of this curve is asymptote with negative x-axis. The same way, if we consider f of x equals to e to the power x, this is a special type of exponential function, and it is very important. It is the inverse function of natural logarithm. That means if we say f inverse x equals to ln x, that is natural logarithm. If we sketch these two graphs in a same axis, it looks like e to the power x, it moves like this, and e to the power x is graph is like this. As this one is inverse function of each other, it will reflect with y equals to x line. That is, this one is ln x and this one is e to the power x. ln x is asymptote with negative x-axis and ln x is asymptote with negative y-axis, and e to the power x is asymptote with negative x-axis. The graph of e to the power x and ln x. Now we want to see if the power is negative, what will be the shape of the graph. So if we see f of x equals to e to the power x and g of x equals to e to the power minus x. So the basic graph is like e to the power x is this way and e to the power minus x will move here. This one is e to the power x, e to the power minus x. And this one is y-axis. So this is the basic graph of exponential function. There are some changes if we change the value of exponentiation or the base of the function. Now, some basic rules. It's like indices. E to the power x times e to the power x equals to e to the power x plus x is 2x. And e to the power m divided by e to the power n equals to e to the power m minus n. The same as the indices rule. For any number to the power x, the indices, they will follow the rules of indices as well as exponential function. Now I will explain the exponential function with some examples from CAIE past papers.
Using substitution, u equals to 4 to the power x, solve the equation 4 to the power x plus 4 square equals to 4 to the power x plus 2, giving your answer correct to 3 significant figures. Example 1, 4 to the power x plus 4 square equals to 4 to the power x plus 2. So how can you solve this using substitution? U equals to 4 to the power x. So u equals to 4 to the power x. So now this equation can be rewrite u to u plus 4 square equals to 4 to the power x. We can write 4 to the power x times 4 square. So u plus 16 equals to u times 16. So 16u minus u equals to 16. That is 15u equals to 16. U equals to 16 over 15. So this is the value of u. So now how can we solve for x? Now we replace 4 to the power x for u. So 4 to the power x equals to 16 over 15. Now we should take the logarithm on both sides. Log 4 to the power x equals to log 16 over 15. This x will come front here. X equals to log 16 over 15 divided by log 4. And the final answer will be 0.0466. This is the answer. Thank you. Solve the equation 2 to the power x plus 1 divided by 2 to the power x minus 1 equals to 5, giving your answer correct to 3 significant figures. So this is example 2. 2 to the power x plus 1 divided by 2 to the power x minus 1 equals to 5. So first we cross multiply 2 to the power x times 5 minus 5 equals to 2 to the power x plus 1. If we shift to the power x here. So 5 times 2 to the power x minus 2 to the power x equals to 1 plus 5. That means all 2 to the power x term in the left side and the whole number or the other terms in the right side. So here 5 2 to the power x minus 2 to the power x is 4 times 2 to the power x equals to 1 and 5 is 6. If we isolate 2 to the power x, it will be 6 over 4, cancel out. So 2 to the power x equals to 3 over 2. So now solve for x, this equation. We write again 2 to the power x equals to 3 over 2. So if I take log on both sides, 2 to the power x equals to log 3 over 2. And as usual, these x come front. You can write this one x times log 2 equals to log 3 over 2. Then x equals to log 3 over 2 divided by log 2. So by using calculator, we can find the value of x equals to 0.585. This is the answer. Thank you.